My name is Ian Watson. I'm the Executive Director of the American Membrane Technology Association. And we're here today to talk to some of the pioneers that were responsible for some of the membrane development work that was done during the early days of the industry. The American Membrane Technology Association is an organization that was founded in 1972 specifically to promote the use of membrane technology, which in those days was still in its infancy, primarily for the treatment of marginal water supplies for drinking water purposes in areas where fresh water may be scarce or would in the future become scarce. I have with me today three gentlemen who were there at the beginning of reverse osmosis, specifically the spiral wound modules. Immediately to my right is Mr. Randolph Truby, Randy, to those of us who've known him a long time. Next to him is Bob Riley, and directly across from me is Dick Sudak. All three of these gentlemen worked in the early 60s and the mid-60s at an organization called General Atomics, which is located here in San Diego. The first question I have is, whichever one of, or all of you can answer if you like. I've always been curious as to why a company that was basically in the nuclear power business decided to get into reverse osmosis.
At that time, the vice president of General Atomic belonged to the Rancho Santa Fe Water Board, and he was also a part of the state of California Water Board, and he had heard about reverse osmosis and the work at UCLA of Sid Loeb. So he decided that General Atomic should try to get into that business. So he assigned three of us to write a proposal to the Office of Saline Water to develop the reverse osmosis membrane that Sid Loeb had come up with at UCLA. And that's really what got us into it. And that started in April of 1962.
So he was looking for water for Rancho Santa Fe. Mm-hmm. He didn't really have a world vision. It was more of a focus vision.
I don't think he really probably had a real world vision at that time.
Who was the guy?
Ed Kreutz.
Okay.
And he had come from the Manhattan Project in Los Alamos.
Yeah. So in 1962, you really started with a research grant from the old Office of Saline Water.
It's $275,000 for 3 years.
That was quite a bit of money in those days.
Quite a bit in those days.
That's good. That was good. When you first started developing this technology, Bob, what did you think you were going to do with it once you had it?
Well, we knew we wanted to try to upscale it, first understand it, upscale it, and commercialize it. That was our motive from the very beginning. And what really helped it along was we had a young engineer there, Jules Westmoreland, and very quickly after we started, he came up with the concept of the spiral wound, and then immediately it looked like we might get this into a configuration that was more practical, because we knew that plate and frame just wasn't going to make it at that time. So I think it was really Jules' idea of the spiral. And
how did you know you had to have more than one membrane element in a vessel?
Well, you had to package a whole bunch of membrane and just, you put one vessel in each one, you got connectors, and it would be economic prohibitive, huh?
So it was really economics and not so much the fact that you needed to limit the recovery in each element?
It was also the boundary layer and concentration polarization. Dick and his crew made some 4x40 elements that had about 50 square feet.
That was when we upgraded River Valley.
Exactly, and Al Riedinger, who was my boss, had me take elements and run them in what he set up the experiment that I'd run it at half a GPM feed flow rate, 1 GPM, 1.5, 2, and all that, and plot salt rejection. And it became very obvious that you didn't have very good salt rejection until the brine flow, or the feed water flow got up, which was the brine flow as well, to a certain point. And it was the early concentration polarization boundary layer work. And it basically said that from an element that would make maybe a half a gallon a minute of permeate, you had to have at least 2.5 to 4 gallons a minute of concentrate flow. Well, that's not economic. Like Dick said, you don't have good economics at that level. So putting them in series became an obvious way to get more permeate per unit volume of feed water.
When we did the River Valley thing in here, it was 5,000 milligrams per liter, 7 milligrams per liter iron, and 5 milligrams per liter manganese, huh? That was potentially high fouling source.
Right.
And a lot of people would say, oxidize it and get that iron and manganese out of there, and put in filters and do this and do that, and it costs a lot of money. And IS just calmly looked at it and said, that's stupid. You got one of the best filters in the world in this sandy groundwater here at the riverbed, number one. And number two, you keep the oxygen away from it, it ain't going to come out.
Right.
And lo and behold, that just, cut the price of reverse osmosis considerably, people using the old head.
Right. Right.
And IS was really good at that.
It's safe to say we were very good at the technology and not so good at how to bring it to the marketplace. we did some nice jobs, did some nice systems. The work in River Valley, TI, that was all great work. It was very important. But how to take that and make it into a business that made sense and was profitable, we struggled with.
Right. What was to become one of the early thin film composite membranes?
Yeah.
Non-cellulosic membranes?
Yeah, we developed that, started the development of it at General Atomic. And we started initially, thin film composite membrane was a cellulose acetate thin film on a porous support. And we'd scaled that up to a seawater desalination plant that operated in small spirals at SeaWorld. And we could see that wasn't going to make it because we had compaction problems, and so then we started off on the interfacial formation of thin film composite membranes, and then we found polyetherurea thin film composite membrane chemistry, and we upscaled that to pilot plant production, 40 inches wide. And then the company sold, while we were still in the R&D stage, the company sold the Jetta job, which was a huge job at that time, and we had to turn that whole operation into a production facility.
Yeah, that was
24 hours a day for over a year.
That was 1977, I think?
That was 1977.
Yeah.
Biggest seawater system in the world in a very rapid time frame.
Right.
As
Yes,
Bob said, we pressed every piece of equipment we had into service and really made a lot of people very unhappy.
Yeah.
Well, you were working on, I think you called it the MSI 400 composite membrane?
We only worked on composite membranes, okay? And we came up with good brackish water membranes and tolerable seawater membranes. And that's what Bartlett set up hydronautics on and got it going.
Right.
And I stayed with Bartlett's for 4 years, I went to 1980, and then I set up separation processes and spent the next 23 years working. Another person that I think was very influential in getting a lot of things done, he wasn't a very pushy guy in getting his ideas across. In fact, he'd give you 2 or 3 things and you'd pick out the ones you wanted to do. But Al Riedinger.
Yeah.
Al Riedinger
Very
was one
well.
of the sharpest people I've ever
He
met.
was.
He's one of the nicest guys I ever met. And he did a hell of a lot in terms of getting ROGA division into a good technical state.
I really think that was the key for General Atomic and for all the work that was done, was that you had Merton and Lonsdale, who started out and brought in people like Bob and Dick, and then later on Seymour and and Al Riedinger and Jerry Foreman.
Right.
And they had a lot of very creative, very bright folks who did a lot of hard work, and they all brought in a lot of people who who worked hard on developing cleaning solutions and pressure vessels. The first fiberglass pressure vessels came out of General Atomic.
That's right.
And it was Pete Darby who was hired,
Right.
and Rick Leeson. They were both hired to develop that FRP
Right.
pressure vessel. And they did, and
It
then, of
was-
course, Pete went off.
It
and-
was, for a while, almost anybody that you met outside of Fluid Systems in the membrane business had at one time worked at Fluid Systems.
some sort of an
It was like
association.
Membrane U.
Mr. Breitling was very aggressive, and he sensed that there was an opportunity there, and he really moved aggressively, and he sued us.
Very-
Ultimately, we were not, and he has accused us of antitrust. General Atomic was found not guilty of the antitrust, but we were found guilty of some contract violations, and I believe we paid $200,000 or something, plus our legal fees, which were in excess of $1 million.
Yeah.
But it really hurt us in the market for, I'd say, it started in, he filed the suit in 76, and it wasn't decided until late 78. And it was so traumatic, I resigned when it was over. When it was over, I was exhausted and emotionally drained and frankly unhappy. And so I left and went to work for Aqua Media for 5 years.
Right.
But it was exactly a result of that lawsuit.
Right, right. That was, you've seen the industry develop from its very beginnings. And are you surprised at how much has happened since then? Or did you sort of expect that were you so excited by what you had done that you had a vision of it expanding and going into places where I'm sure you never thought it would go initially?
I felt that way,
You got that right.
yeah.
We even christened or coined a phrase for it. We called it Romania, reverse osmosis mania. And people would look at this business and say, my gosh, this is the greatest thing ever, it's gonna be great, and they would get Romania. And once they had the fever, and they would they'd want to do everything and do it immediately.
Yeah.
But we all thought it was gonna be big and develop, and it did, but much slower than we thought it would.
Right. Where do you think we go from here? I mean, we've got membranes now, membrane materials now that far exceeded anything I thought would happen 10 years ago. We're looking at large diameter, large format systems. Plant sizes are getting bigger. I mean, I worked on a project here in Israel recently. It's 110 million gallons a day seawater plant. I never would have imagined that a while ago.
Right.
So where do you think we can go from here?
I delivered the keynote speech at Microfiltration 3, I believe it was, for the National Water Research Institute.
Right.
And I ended it up by saying that the future of water treatment belongs to membranes. Microfiltration, ultrafiltration, and reverse osmosis. And I honestly believe it. It's just going to take over everything in terms of water treatment.
Bob?
I agree with Dick. I think the only thing that may slow it is the energy situation. But I think membranes are really going to grow and do well.
Good. Randy?
I actually think we're at a point where we're going to take another step function up. You know, the introduction of the Spiral 1 element represents a real technological breakthrough, and it moved things ahead. And the introduction of the thin film composite membrane represented another real breakthrough and moved things ahead another big notch. And frankly, isobaric energy recovery devices, which have made the energy consumption better, have moved things up another big notch.
That's true.
And I think some of the stuff that's being done now, like we heard about at this AMTA conference this week, including these nanomembranes that some of the folks are working on, the forward osmosis membranes that Bob's still doing work on, the PRO, pressure retarded osmosis membrane, and the chance to make power based on Sid Loeb's early work and early concept.
Right.
And I think those things have a chance to come to fruition. So I think we're on just about ready to make another jump forward into a whole new area. And that's, at the same time that's happening, these seawater desalting plants and wastewater reclamation plants are being built all over the world in huge sizes.
Right.
I think it's it's great. The technology that Bob and Dick and I started working on, and you as well, Ian, is now to the point where it's a real business, a real technology, and really being counted on all over the world. And now there's a whole bunch of new stuff that's coming out of it, and I think it's going to even push it further ahead.
Yeah,